have a little bit of, I have just a little over a half page left.
You should be okay. You should be okay. Okay. Can somebody tell me in their 7th grade mind, what does absolute value mean?
Raise hand.
Raise hand, yes.
It's the distance that it is from 0.
The distance that it is from 0. Right. So,
blow our minds and tell us it's something completely different.
I'm not going to blow your mind. I just wanted to make sure we do, right? So, right, no, totally there. So the idea is that it's distance. So what do we know about distance?
It's only positive.
It can only be positive, okay? So if I'm looking at old school number line, just for the fun of it, and let's say I have 0 here. 1, 2, 3, 4, 5. Let's say that. 1, 2, 3, 4, 5. Let's say that. Okay. So what is the distance from 0 to the right? It is 5 to get to 5, right? What is the distance from 0 to the left?
5.
5. It is 5. By definition, the definition of the absolute value of x is truly what we consider a piecewise function. Okay. And I just want to show you this so you have an idea of how this works. Okay? It's positive x when x is greater than or equal to 0. Think about the numbers that are bigger than or equal to 0. Okay, 3. Okay? So plug in 3. The absolute value of 3. So the absolute value of 3 is 3 because 3 is bigger than 0. Does that make sense? Okay, it is negative x when your x is less than 0. Think about the numbers that are less than 0. What are the numbers that are less than 0?
-1, -2.
1, -2, -3. So the absolute value of -2, because it's less than 0, plugs into this spot. So it'd be like negative, -1, negative, -2, and so on and so forth. Okay? Algebraically, that's why the absolute value, also known as a modulus function, works. Okay? We know it as the distance from a specific spot, but algebraically, that's how this works. So the question is, can I ever have, like, not even for me, for my husband.
Oh,
For the other.
4 and 5.
Okay, so.
Is another
I could probably do it, but I don't know like the names of terms.
I got you. Okay. Okay, so we understand the concept of it. Yes, no, maybe so.
Yes.
Okay, so there's two different types of inequalities, also known as modulus function, that we'll be working with. Okay, the first one is when it's actually equal to. The other one is when it's an inequality. Can you recall anything special about working with an inequality?
The table.
The table, the chart.
Raise hand.
Raise hand.
When dividing and multiplying by negative, the inequality sign flips.
Oh, I like that. That's good. Yeah, I didn't even go there in my head. That's good. Okay. So, if you're working, I'm going to give some examples that they have in the book, by the way. Probably my best bet. If we start off with something that looks like this. Okay. What do we know about the absolute value? The resultant has to always be
Positive.
What is one of the way to counteract this to know that it'll always be positive? Creativity in your brain now for a minute. What is something that we can do? Yeah.
Square it and then take the square root.
Well, yeah, actually, I like it. Actually, square both sides. If I square this, what do I know that happens?
It's
positive.
Yes.
If I square this, what happens? Again,
Positive.
positive. So I know the absolute value has to be. So if we square both sides, okay, then we solve for x, we will have the special numbers that we need to utilize. So when you have an equality, you're actually going to get specific answers. When you have an inequality, you're going to get a range of answers. Does that sound familiar from last year? Okay, so how do we square something that looks like this? We'll disregard the absolute value signs. And how do we square it? We do what to it?
Foil it.
We foil it. What's a mistake that somebody will make out here?
They just pull in the 2 onto the X
Pull in
and
the
2.
2, and that makes me cry. You remember that, right?
No.
That's a big no-no, and I cry easy now. So we have 2x minus 1. Okay, oh, I should actually do what I did over there. 2x minus 1. All right, are we good so far?
Mm-hmm.
Okay, foil, both sides. So we would have x squared, right?
Minus.
4x
Uh-huh.
plus 4. So far, so good?
Yeah.
Equals 4x squared minus 4x plus 1. Are we good?
Yes.
Comfortable? So far, so good? What should we do now?
You should combine like terms,
Bring it
that
on
sort
one
of thing.
side. It screams.
I'm a trinomial, set me to 0. Okay. Yeah.
So the hard part, the new part, is the squaring both sides. The rest is old school. Okay? So I prefer the x squared to be positive, so I'm going to bring everything over here. Everybody cool with that?
Yes.
Okay, so I'm going to subtract x squared. I got 3x squared. I'm going to add 4. That's gone. I'm going to subtract 4 minus 3 equals 0. Did I lose anybody? Okay. What do I see in common?
3.
So I'm going to factor out the 3. What's left? That. Are we good so far? Now
Yeah.
what?
Yeah.
So what about the 3? Will that ever equal 0?
No.
So that's not part of my answer scheme, right?
No.
Yeah,
We just-
go ahead.
Where'd you get the minus?
Where did I get the minus? Okay, when I factor out the 3, I pull it to the front, and what's left, it's really like saying, taking 3 out is really like multiplying it back through to kind of check yourself. Does that make sense? Okay. Okay, so what do we get for our answers? X equals 1, x equals negative 1. Oh, but you can't have negative 1, is it? But you can, because it's the input. Remember? The
Yes.
input could be negative. The resultant, what comes out, is what causes it to be positive. Did that make sense? Because some people look at this and go, but we can't have and I just want you to be careful with that. Yeah. Okay. If the question itself looked like this, now tell me something.
You can't.
That's not possible.
It's not possible.
Because
Because an absolute value, remember, always results in a positive answer.
It's like a square root of -1.
Correct. It's yeah.
Yeah.
So does that make sense?
Yeah.
Okay. Anybody have questions on how this worked? It's actually really easy.
Yeah, it's not hard.
It's not bad.
It's
Yes.
just remember
If you have an absolute value on one side and one on not on the other, how do you get rid of the value?
It's the same thing. You just square.
You just square it?
You could square. Yep, and that'll do
remember
your
you
answer.
squared both sides.
Let's,
Yeah.
We'll do that. We'll do one of
It's
those.
kind of like a square.
Kind of, sort of, yeah. Let's see what we got going on.
And remember, square both sides and then forget.
Now, another way you could do it, and let me show you. What are you giggling for?
He's beating his
You
pencil
got out
up.
of my pencil.
You broke your pencil?
He's
No,
beating
it
it up.
doesn't work. It was
Oh, no, don't do that.
out of it.
Nope.
So, if I have an absolute value on one side, right?
That's a really nice graph that has in the book. I just saw it.
You like that? It looks like a mustache. It's the absolute value of the sine of x. Really, I know, exciting. Okay, so, what is the answer to this?
Plus or minus like 3.
Plus or minus -3.
No, plus or minus 3, sorry.
Plus or minus.
I mean, technically, yes.
I understood where you were going. Let's do it with the square just to show. You know it's 3 and -3. Why? Because when I plug in a 3, output 3. When I plug in -3, output 3, right? But what happens if I did square it? I wanted you to see why it works. So if I squared both sides, I get what? X squared equals 9,
9.
yes? And then when I solve for the square root, what happens?
it's plus or minus.
I get
Square it and
plus-
then take the square root.
Well, you could, right? I just wanted you to get a feel for it. So how would this work?
Square both sides.
Again, you could square both sides. It's all, yes. I know, it's because of where you're sitting, the flag. I really should move that, but I can't
Do
really
you wanna
move.
move all these
How about
desks
we move
back
the
one?
desks back?
Yeah.
There we go. Move them just way back. I don't know why they travel forward.
Miss K?
Yeah.
So whenever you square something that has the absolute value over it, it gets rid of the absolute value.
Right, that's right.
Okay. So it's almost as if it wasn't even there at all.
The floor's like,
I know, it's sometimes the tile sticks up a little more and then you push it, you go duh, 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 duh.
Yeah,
I've done that.
exactly what happened.
It's awful. Good job.
Yeah, the people who laid the tile in my house didn't flat it on.
I always find
Sweeping,
myself,
it doesn't work.
I always find myself tripping over it. Okay, so let's go ahead and do this one. What do we get? If I square it, right? Are we good so far? Now what?
Foil the x minus 4.
And I'm not sure this one will work really well. What?
X squared minus 8x plus 16.
So x squared minus 8x plus 16 equals 25. Now, before we go any further, this is really not a bad problem if I'm trying to, for example, what minus 4 is 5? Trick question.
9.
Oh.
9. So
yeah.
one of my answers should be 9, right?
Yeah.
Are we good so far?
Mhm.
And then what else would be an answer? Like, pretend the absolute values aren't there for a minute. I want you to get a, negative 1, right? Because negative 1 minus 4 is negative 5, absolute value is 5. My answers should be 9 and negative 1. Let's see how this works, right?
Hope it works.
We hope, cross fingers, right? So we have x squared minus 8x, subtract that 25 over, which is minus 9, equals 0. It's created out of a trinomial, blah, 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 right? Factor me in that voice again.
And that's right.
And we get 9.
And negative 1.
So, to me, I know algebraically, it's easier than me having to go, because sometimes these get more complex, right? Are we good so far?
Mm-hmm.
Okay. Now, what happens when I throw the inequality in? No, we don't cry.
are you sure?
I'm pretty sure I'll cry.
I heard it, but we don't.
I'm good.
I know.
Brian, let's just remove out a B.
Yeah, well, I'm still gonna
No, you're not.
cry.
I was about to say that you don't cry.
Okay.
I've cried over math more than once.
So, I suggest, for a moment, we pretend that the greater than or equal to is not there for a moment. Okay? Let's pretend it's not.
That's for things that are not there at all.
We'll come back with it in a minute. But what we're going to do is we're going to just do the problem as if it's an equal for a moment. So how would we have handled the equal?
Square both
We would have
sides.
squared both sides, okay? So that's what I want us to do first. So I'm going to square both sides, and I get x squared minus 4x plus 4 equals,
4x.
thank you, minus
Well,
12x close to 6
yes, very close.
plus 9. Wait, catch, yes.
12x squared.
That's an
That's
absolute
2.
value.
That's absolute value.
I did the same thing.
144.
I know, that's what I did the same thing, and I was like, wait a minute.
It confused me because like the 12, the
Oh,
so-
totally there, gotcha. Now what do I do?
Now you're going to bring it to one
Bring it
side.
on the one side, right? I'm frightened of the negative, so I'm going to bring it over here. So 3x squared, add that, I got negative 8x. Subtract that, I got plus 5 is 0. Are we
Oh,
good?
That doesn't look pretty.
Don't be scared.
It's not pretty.
Okay, so we're going to factor it out, hopefully. I'm assuming 3x and x,
Mhm.
right?
Yep.
I'm going to do a 5 and a 1, both negatives.
Yes, that works.
It did, right? 3x squared
Yep.
Yep.
minus 8x plus 5. Sweet. What do we think? So what are my two special numbers?
5/3 and 1.
Yeah.
Nice.
I'm good at that.
Now what do we do? So think about it.
have to do the chart.
Think about it in chart form, right? So the way you think about this is I know that my range of numbers, okay, what's smaller, 5/3 or 1?
5/3. Good.
1.
Oh, 1.
Good job. So,
It's been a long year.
we just started.
By the improper fraction.
Very
Tricked by the improper fraction.
I see a fraction, I think it's smaller.
So, we know that it goes like this, 1 and 5/3, right?
Mm-hmm.
We know that the things could be less than or equal to. So far, so good. Does that ring a bell? It could be between, or
Greater than
it could be,
or equal to.
yeah. I shouldn't have erased it.
Memories.
Does it? Like fond memories? Oh, okay.
I'm still debating.
It's actually not bad.
Do we have one of those on the test?
Yes, we did.
I'm pretty sure.
Should have.
Oh,
Yeah, we had two.
very good.
Okay, now, are we good so far?
Yeah, sure.
Now, what I suggest is pick a number that falls into your category.
0.
Okay, so 0,
4/3.
Or third.
yeah,
Yeah.
yeah,
You're not wrong.
because this is 3/3 and that's 5/3, right?
Yep.
And then something bigger than that.
6/3. Or 2.
2.
Yeah.
6/3.
Let's make life easier for us. Okay, starting with the original function, and I prefer us to write it above it because it gets a little hairy because they're absolute values and all that. So I have the absolute value of x minus 2 is greater than or equal to 2x minus 3. So far, okay? And ultimately, what are we trying to do? To see whether it's a yes or a no. So if I plug in 0, I'm going to show the work. So 0 minus 2 would be -2, absolute value is +2, right?
Mm-hmm.
And if I plug in 0 here, I got -3, absolute value is +3. Is that a yes or a no?
No.
It's a no. Does that make sense?
Yes.
I'm going to guess that it's a yes next and then a no. Let's just make sure.
Mm-hmm.
Okay. So if I plug in the next one, which is 4/3, so 4/3 minus 6/3 would be -2/3, which comes out to be +2/3. Okay, and then 4/3 in there would be 8/3 minus 9/3 would be -1/3, +1/3.
Yes.
I don't like fractions.
Don't be frightened, just like your teacher. Okay. And then the next one was 0, that's nice, and -3, right? So it would be 0 is greater than or equal to 3. That's a no. So do you agree with me that that is the answer
Okay.
set?
Yeah.
Okay, I get it.
It's not bad. It's truly what we learned last year. What's the only difference is we put the modulus function into it. Okay? Are we good? I know. Absolute value. What's the modulus function? Okay, what about this one? I'll let you try it without me. Well, before I square it, do one,
Move it over.
move something over. Because why? Because if I'm squaring this, I'm foiling this. Don't want to do that. So I would have this. Right?
Mm-hmm.
Does that make sense? Yes, no, maybe so?
Yes.
Now, when I square it, like so, are we good?
The negative doesn't matter.
Because I'm going to actually square it,
Yes.
so it does matter.
Well, it just becomes 1.
Right, it just becomes +1, right, rather than -1.
Yeah.
Yeah?
Yeah.
Okay.
Yeah.
So what happens over here? This becomes x squared minus 4x plus 4. I was going to let you do this by yourself, wasn't I?
Yeah.
Okay. Sorry. Hush, hush. Hush, hush.
That's okay.
Yeah.
Would there ever be an example where you had a number in front of the absolute value sign?
Yes. What would you do with that number? Like a 3, for instance.
You would just distribute.
You would, well, no, you would square it.
Yeah.
So, square it before you distribute it. Does that make sense?
Yes.
So, like if it's 3 absolute value of something, do 9, square that, then distribute your 9 through.
So
Right.
that one turns into a 1, so it doesn't really do anything.
Correct.
Okay.
Yes.
Because the negatives on the outside of the absolute value bars, we distribute it to every one of them.
After the fact. So that was okay. So that's a good question. We just had the discussion over here. So how this happens is you're going to square this thing to become a 1, and you're going to FOIL this and distribute the 1 through. If this was a 3, you would square this to be a 9, FOIL, and distribute it through.
Okay, but because it's negative and it's squared, it'll just be positive 1, right?
Correct.
Okay.
And then when you distribute it,
You know, this isn't like low-key entertaining. It's like, it's math.
This is exciting, it's low-key entertaining.
It's low-key entertaining.
Because you kind of like it. It's comfortable, and you feel like you could do it.
Yeah, well, it's because like I like factoring.
Oh, well, there we go.
Setting things up to factor, so it's
So do I.
it was like the one thing that I understood now for one.
because if it works out, it's so nice.
So pretty, right?
Yeah.
You get kind of excited by the whole thing.
Yeah.
All right, did you see what I did?
Yeah.
And then when you admit it, that makes you intellectual rock star. Did you guys ever see that? I found it this summer at TJ Maxx.
What?
Nerd, I prefer the
love that
term.
story. TJ Maxx is a great story.
I know. Intellectual rock star.
Go home and figure out before they crime.
That's cool. I know mine's not. Ends in 72. Okay, so what am I going to do here?
Cancel off the X's.
Right? And so, and then, is everybody cool with what I'm, okay, I'll just show you.
I had to flip that one around. I was like,
You felt a little uncomfortable with the whole thing.
yeah, I was like, oh,
I'm going to get rid of the x squares. I feel good with that, right?
Yes.
Yeah.
I'm going to add 4x over here to get 2x. I'm going to
Yes.
subtract 1 to get 3. So 3 halves is x. Does it make sense that I only have one answer?
Yes.
Yeah.
Yeah.
It makes sense. Potentially I could have 1 or 2 in this, but they're exact answers. Does that make sense what I mean? I mean it's not a spread of numbers. Mike, will you guys let her in? Thank you, hon. All right. Are we good?
Mm-hmm.
Okay. Are you guys feeling comfortable? How about you take out the worksheet, we'll do 14 together.
okay. I understood it. They're like, you know what? Let's put the letters. We gotta make it look like a sentence. Oh.
It wanted to curve and it shouldn't have. Find the set of values of x satisfying the inequality where a is a positive constant.
Especially in the X.
All right, what do we do? What do we do?
I'll square both sides.
Okay. Can you do it without me? Square both sides. Maybe. Plus 4a squared.
Yep.
Okay, good.
Mm-hmm.
When you squared the other side, what'd you get?
X squared.
Because you have a 9, right?
You distribute the 9,
After the factor.
9x squared.
So I'll do it slowly. Okay, so you got what, 9x squared?
Minus 18.
Good.
Plus 9 is
So far, so good. Okay, before I go further, is there anybody out there going, huh? Help? Except for Brazelton. Sorry, buddy.
Are you okay?
You'll figure it out, are you sure? It's gonna be on YouTube, because I'm being taped as we speak, so. Okay.
That, and I live down the street, so he can help.
Oh, perfect. I told the parents
I
the other
can't
night that I
drive
had,
anything, so-
I'm an official YouTube star because I had like 10 hits, or 10 search watches or whatever.
10 views.
10 views. Don't even know the word for it. They laughed. 10 hits. Okay, so what does it want me to solve for ultimately?
A.
A.
Solve for oh.
Or X.
X values.
X.
But it's going to be
X
X
values.
In terms of A.
in terms of A.
Okay. Okay, so now what do we do? Don't be scared.
Oh,
So
I'm afraid.
that can come over here as a 5a squared?
Yes.
Mhm.
Yeah? Are we comfortable with that? The 4a, this thing would go over here to become negative 22ax, right? And then over here, I did them backwards anyway. So plus 8x squared. I'll put them in order now. Thank you. You're so welcome. I just got excited. All right.
One of my 2's looked like an L, so it looked like lax. 2
Oh,
lax, and I was
nice.
like, that no.
That's fun. Okay, now what? What do I do?
Factor.
Yeah.
Yeah. Berry method. Quadratic formula.
Have fun with that.
Yeah.
Fun with that one. Okay, so here's what I do know. There's an x here, a here,
And it's 1 and 5.
That's the true.
and it's 1 and 5. Yeah.
Yeah.
So it's a 1 and a 5. And what else do I know about my signs?
Minus, minus makes.
They're both minus, right? So minus and minus. We're on a
And then
roll.
it's 8 and, or not, 4 and 2.
4 and 2, right?
So 4 and 2, let's see. So this is
4
4,
there. And then
because
2.
that would be 20.
And then plus.
Look at us together make one big brain. So we have 4 and 2.
Only we could test.
I like this. That would be phenomenal.
Miss Kay?
Yes.
Could you use the Berry method or quadratic formula for this?
Sure.
Yeah.
Have fun
We
with that.
just, we skipped a couple steps on the berry method,
Yeah,
but we did the same
basically.
thing.
Yeah.
Is that right?
Yeah,
I honestly didn't know that. Okay, so that's cool.
because you're gonna end up like that.
You do in the end, but I just, yeah. Okay, so what are my two values in terms of a? So the first one is going to be 4x minus a is 0, right?
Mm-hmm.
So I add a, divide by 4.
4 is,
So x equals
A over
a over
4.
4. Don't be scared of that.
And then
my
2x
other one is
equals 5 or minus 5
Equals 0. So 2x equals 5a. X equals,
5
what do we think?
Not that bad.
It's really not that bad. So on the homework, we did the hardest of the group.
Is that really the hardest one?
That would be the hardest. The
That's
rest of
not even
them,
hard.
Wait, are those, is that,
That's it?
those values of x satisfy
Don't
the
you have to do
inequality?
don't you have to do the chart too?
oh, it's an inequality.
Yeah, so we're not done.
And no wonder it was 4 points.
We thought we were done.
But we don't know what A
Yeah,
is.
but you don't know what A is. Let me see something for a minute.
Check
If it's greater than,
positive constant.
Since it's a frac, does it really matter what number you plug in for a? Wouldn't it give you the same kind of like ratios?
Could we,
Since
yeah,
it's a
could we
fraction?
plug in x?
you mean use 1/4 and 5/2?
Yeah.
Yeah.
Is that what you're
Could
saying?
you do that?
Let's see.
Is it,
Well,
it
when I was
makes-
thinking,
in my head it makes sense,
We
but I
know
don't
they're
know if
both
it actually
positive.
is.
we know they're both positive.
Correct.
But
There's more to it.
my thought is plug in one of the x's and find a.
Miss Kay?
'Cause you
Yeah.
could
I think I know what to do.
Okay, tell me.
You've got two equations. You can use substitution or elimination to solve for A and solve for X
Plug that in.
and get actual values.
You say it again?
You've got two equations and you can use substitution or elimination to find the actual values of A and X.
That's what I was
Okay.
saying, yeah.
Okay.
Because we could do that. It would
You
get
have-
rid of the x's and then we'd only
You
have
have
a's.
two what?
You could use substitution elimination.
5 over 2a.
No.
I don't think that was.
No, you're not solving for A itself. It's going to be left like that.
But I mean to help you in order to do the chart.
I don't think you can figure out A.
You cannot, but you can figure out the grouping up.
So you just use a fraction like this.
Let's just try the chart. and see
Hold on,
how
let me
it is.
show you something from,
It's like technically it's just.
no, it's from,
Math has a magic.
7th grade, I was in a stupid math
7th
class.
grade
So.
then they told you if it's greater than, then you write it this way. If it's less than, you write it this way.
What way?
You can show the way.
I know, I'm looking it up. It's been a long time since I've shown that.
Yeah. I don't think we ever did that in my math class.
Do you
Never.
have Brown?
And Mr. Brown,
I
the
heard
computer teacher.
Are you still videoing me?
Oh, should I not?
Oh, jeez. It's always going to be bigger.
Yeah.
So you
Right.
have to use a fraction.
So that's, we're gonna set up our little chart for that. That's right.
Right, that was my logic.
Is that your logic?
Yeah, it's something.
Me? Yes.
I was wondering.
Okay, so 1/4, 5/2. Anything I plug in for A, say 1. 1/4, 5/2. What's bigger? 5/2.
Yep.
How about 8?
That
2. That would be
10.
10. What's bigger?
That
Right?
one.
So,
Oh.
so A over 4 is going to be, these are my two specials, right?
Mhm.
Does that make sense what I just said?
Mhm.
Okay, so it's going to be x is less than, just plain out less than, a over 4. A over 4 is less than x is less than,
5/2 A.
thank you. I keep wanting to put a greater or equal to. And then 5/2 a is less than x. Pick an x.
0.
I mean, can you really pick it?
But you don't really know for sure exactly if that number is
Has
going
to
to
be
fall into
positive,
play.
right? Or-
So pick
Well, yeah.
Just 0.
the first one, you can pick a negative number.
You could, because x could be like less than, right?
So negative 1.
Or even 0.
Yeah. 0. Just make it easy.
Just
Okay, what falls between, like, for example, 1/4 and 5/2? 1. Yeah. So we're gonna just pick 1.
What?
Well,
Oh, because whatever A is.
1A, right?
We're kind of like assuming here.
We're assuming. Yeah.
Hardcore.
So then you just come up with a number for A, plug it in, and plug it in everywhere, and then
Yes.
see what you come up with.
As long
So
as
you
it
could.
meets the constraints that they're giving you.
The only thing is it's positive,
Yeah.
right?
Yeah.
So do you want to pick, like, for example, 2? The number 2 for A?
5/2, you'd have to pick 2.5 for,
No. Like for A.
I think
For A.
1.
Like if you pick a 1, right, you got 1/4 and 5/2. Yes,
We could just, A could equal 1.
that's right.
I think that's the easiest way to go.
It where it's hypothetically 1/4.
Right. We did in the brain, right?
Hypothetically 5/2.
Okay, now pick a number that's bigger than that. 3. Okay, now. So plug it into our original, right? So 0, and remember that's 1, right? So 0 plus 2, basically, so that's 2. And then greater than, plugging my 0 there, -1 absolute value is 1 times 3, right? Is that a true statement? No.
That's not it.
That's a no. I thought Zach was saying yes. I got nervous there for a minute. His head's just a bobbing, yeah? It's like, oh no, Zach, you sure you wanted to finish your test today? Okay, now picking 1. So is everybody cool with what we're doing? So 1 plus 2 is 3, right? And then 3 times 1 minus 1 is 0, yes? So 0. Is 3 bigger than 0?
Yes.
Yes. And what should happen over here?
No.
It should be a no, right? So our answer is that grouping. Is everybody good?
Mm-hmm.
That was like the most difficult. If you look at the ones prior to it, they're definite
Cakewalks?
cakewalks compared to this, right? Yeah. Are we feeling good?
Mm-hmm.
Okay. Beautiful. Do you like this lesson? I mean, do you think that the test on Thursday will be good?
I mean,
As long as you don't do that.
worst comes to worst, I don't